In this video, we're going to go ahead and implement table per hierarchy for our launcher and our client data types. Now, first of all, I want to go ahead and write a class in my base project that represents a version number for either our client or our launcher. I want the version numbers to be sequential, but I also want to encode a date time into them. So a version number will be a number followed by a Unix date time. And when I say Unix date time, it's the amount of milliseconds that have expired since, January 1st, 1970. And that gives us a very convenient little number that we can append onto our version string. Now, there's a variety of ways to handle versioning in all bits of software. We can do the major minor revision strategy. We can do quite a few different strategies, but I just want to keep it simple and straightforward, and we can always change it later. So what I'm going to do is I'm going to create a class, and I'm going to call it build number, and this is going to be in my base project. My build number will have a couple different properties on it. It'll have a uint for a timestamp and a uint, or how about a ushort for our version? So a ushort version and a uint timestamp. We're going to create two properties out of that. I'm going to make this class immutable, and I'm also going to turn this class into a struct instead, actually. By turning it into a struct, I'll have to make sure to invoke the base constructor. As you might recall, a struct always has a default parameterless constructor that sets all of our properties to their default values. And in order to access the struct, we have to It's this. We have to invoke that parameterless constructor from our constructor that invokes our properties. We could avoid having to do this right here if we were to assign both version and timestamp to a value without accessing their properties. Unfortunately, that isn't possible because these are automatic properties. Next up, I'm going to go ahead and implement my quality members. So as you see, we get an implementation of equals with a build number, equals with an object, get hash code, the equality operator, and the inequality operator. So that's what we want for that. Next up, I'm going to write a toString method. So I'm going to say public override toString. And toString will simply return placeholder.placeholder. The first placeholder will be version, and the second placeholder will be timestamp. So that'll give us a nice little convenient way to present our build number to our debugger and our other bits of our system. So now that I have the build number in here, I'm going to want to go ahead and build out my class hierarchy in my data folder or data project. Under the entities namespace, I'm going to want to create the upload class as well as the launcher class and the client class, all of these representing entities. So let's start with my upload class. I'm just going to call it upload. It will be an abstract class. It'll have a public int ID, public get set. It'll have a public build number version, public get set. And then let's go ahead and also throw in a public date time uploaded at get set. So we have our ID, our version, and our uploaded at for our base upload class. So really, this is all we need for both our launchers and for our clients. They don't need anything more complicated. So we can go ahead and create two more classes, one for launcher and one for upload. So launcher inherits from upload, and then one for client, and client inherits from upload. And we now have our client, our launcher, and our upload entities. Next up, I'm going to go into my database context, and I'm going to add a DB set for each three of these entities. I'll say public DB set uploads, public DB set launchers, and public DB set clients. Okay, now that we've added our entities to our DB context, we can go ahead and create their migration. So I'll click on the Package Manager console. I'll make sure that I set the default project to buzzmmo.data so that we're working against our data project. And I'll say add-migration upload, or add upload tables, or something like that. So I'm going to hit enter, and it's going to create a migration for my class hierarchy. So before we run this migration, after Visual Studio freezes and then finally generates our migration like we asked it to, we'll verify that it's indeed going to be a table per hierarchy. I'm not entirely sure if it is going to be a table per hierarchy, but we'll find out. It'll be an adventure. Yes, it does by default do a table per hierarchy for our DBO uploads. Notice that it just created one table called uploads, which is our base type. It created our ID, our uploaded at, and our discriminator. But you'll notice that our timestamp, or our build number, is not there. That's because we need to do a complex type, which can be done in a couple of ways. Either we go ahead and override our, we go into our base project and we annotate our build number with a special attribute, which will inform Entity Framework that this is a complex type that I want to map. Or alternatively, we could override the mapping using the Fluent API. And I'm going to do that because we're going to need to override the way that this maps anyway and override the conventions because I don't like the discriminator being a string. Notice how the discriminator right here is a string. You know it's a string because it's an envarchar type. Well, that's going to be problematic. I don't really like storing discriminators as strings. I prefer to store discriminators as an enum with an integer field. Because that should be more efficient and it's a lot cleaner. So I'm going to go ahead and delete this migration. I'm going to delete add upload tables entirely so that I can override the mappings that Entity Framework will create and then recreate the migration in the way that I want it to be. So how do we override the mappings? Well, for what we've done right now is we've been using their convention-based mappings in its entirety, so that's everything's been convention-based mapped. Well, we want to go ahead and change that behavior. I want to override how it's going to map the upload table and how it's going to map the client table. To do that, we go into our database context and we override the onModelCreating method. So I'm going to say protected override onModelCreating. I'm going to remove the call to base because we don't need that. As you can see, if we go into our base, and I'm also doing this to make sure that I'm right in saying this. Yeah, our base method does nothing anyway, so we can remove the call to base.onModelCreating. So let's go ahead and fix our mapping. I'm going to change this this parameter name from model builder to mapping. Then I'm going to say mapping.entity upload dot let's do dot map t goes into okay, so let's do dot map and let's t goes into property, or how about, is there a complex type? No, there's property version. I have no idea if that'll work. Configures the properties that will be included in the mapping fragment. If this method is not called, then all properties that have not yet been included will be configured. I have absolutely no idea what this is going to do. Let's go ahead and fire up our, let's go ahead and add a migration, add upload tables, and see what happens. Property version of type upload cannot be mapped because it's been explicitly included from the model, or is of a type that's not supported by the DB model builder version being used. So let's go ahead and map each column of our version manually. So I'm going to say property f version dot timestamp t property f version dot version. Now let's see what it'll do. See, this is fun. It's an adventure. The version timestamp. It's not going to allow me to map a uint, unfortunately. It's probably not going to allow me to map a ushort either. Let's see if we can... as column name, version timestamp. So we can't override the type of it, and we can't map this the way that we want to. I wonder what would happen if we casted this to an int right here. This probably will blow everything up. We're probably going to have to go back into our build number and timestamp. Yeah, it's not going to let us do it. It doesn't want to. And here's the problem. MSSQL does not support unsigned types, whereas MySQL does support unsigned types. So, unfortunately, Entity Framework is not going to let us map a ushort or a uint to our database directly. If we were using Hibernate, this wouldn't have been an issue, but unfortunately we're not. Well, I still like some of the stuff that Entity Framework has given us, but I'm not a big fan of the fact that we can't do some of the things we want to. So instead of doing a ushort version and a uint timestamp, I'm just going to do a short version and an int timestamp. The int timestamp will give us enough values to go fairly far into the future, so I'm not terribly concerned about that. I'm also going to regenerate my equality members. Hopefully my get hashcode method didn't change. It looks like it's about the same. Okay, so our equality members are the same that they were as before. So again, all we did is we changed the short to or ushort to short and the uint to int on our build number so that we can map it with Entity Framework. Let's go ahead and jump back into our database context and try to add the migration again. Timestamp cannot be mapped because it's been explicitly excluded from the model. So this is getting kind of annoying. Oh, I think I'm forgetting something. I think we have to actually go about describing the complex type or the build number type to Entity Framework before we try to map it. It seems that we can't map the individual properties of our build number class to our database context, but what we can do is we can say mapping.complex type build number, which of course will bring in our system buzzmmo.base, and then we can go ahead and say dot property, t goes into t version dot oh, you gotta be kidding me. The type build number must be a reference type in order to use it as a parameter t complex type. So, as it turns out, Entity Framework isn't even going to let us map structs. But that's okay. Build number can be a class. I wanted build number to be a struct because it's very conceptually, it follows along with the kind of feeling that we would get with structs. But it seems that we're not going to be able to do it as a struct. And it's okay if it's a class. We're not going to be using this class so many times that we will run into any performance implications by it being a reference type and not a value type. So let's go ahead and convert build number to a class so that we can map it to our models. So first of all, I must make it be a class instead of a struct, and then I get rid of the this. And then I regenerate our equality members because all the equality members were based on it being a struct and not a class. So let's regenerate our equality members. And we get the same stuff back from ReSharper. You might want to pause the video if you don't have ReSharper to generate that for you. But the difference is that we now do things like null checks, which is of course going to be very important to do because this is now a reference type that can be null as opposed to a value type that cannot be null. Okay, now that we've done that, we can finally come here and say mapping.complexType. I wonder if there's an easier way to... Actually, I bet if we do this instead, if I say var build number map equals mapping.complexType build number, and then I can say build number map dot property t goes into t dot version, and then build number map property t goes into t dot timestamp. Now that I've done that, I might not even need to map the upload at all. Like, I might be able to just keep with the existing conventions now that I've informed Entity Framework that build number is a complex type. Now remember, we could achieve the same thing of doing this if we added the complex type attribute to the build number class. I don't want to do that though, because that'll require us to put a assembly reference to Entity Framework in our base project, and that's unacceptable to me. So let's try this for the 15 millionth time and hope that the Entity Framework gods cut us a break. And they do! We see that we do indeed have a short being generated, and it's nullable, and it's not nullable. And yeah, we have our version and our timestamp being mapped correctly, and everything is right in the world. So let's go ahead and do one more thing. So like I said before, I wanted to override the default discriminator concept, or the default discriminator behavior. So what I want to do instead is have it map on an enumeration as opposed to a string. So I'm going to come in here and I'm going to create an enumeration. I'm going to create it in my buzzmmo.data project. I'm going to create a new enum, and I'm going to say upload type. I'll have an upload type of launcher and an upload type of client. Now I'm not going to reference the upload type anywhere in the buzzmmo.data project for now. In theory, I could map it if I wanted to. I could easily add the upload type property to my upload base class, but I don't want to do that. I'm just leaving the upload type enumeration around so that we get two convenient little identifiers, one for launcher and one for client, and we'll be using this as the discriminator. Let's go back into our migrations and delete our add upload table once again. This also shows you guys how to kind of debug issues that you might run into with Entity Framework. Telling it to create a migration for your changes will give you a very good idea about what Entity Framework thinks about your mapping. And if its assumptions are incorrect, well then we just jump into our database context and we make the modifications. Okay, so what I'm going to do is I'm going to say mapping.entity upload, and the way that we do we override the discriminator value of a table per hierarchy relationship is that we do a mapping.entity on our base type, then we do map, and we pass in the derived type as a generic parameter. So the derived type, the first one we'll do is client. And on client, I'll say t goes into t.requires. Then we need a value. We need a discriminator value. Let's see. Well, we need to go ahead and be able to access the discriminator, which I seem to have forgotten how to actually do. I'm a terrible person, aren't I? Well, I already know I am. I believe it's just going to be discriminator. We'll see if we fail miserably or not in a second when we generate our migration. So how do we spell discriminator? D-I-S-C-R-I-M-I-N-A-T-O-R. So we'll say t requires discriminator dot has value, and then we're going to pass in upload type dot client, and then we're going to do that again for launcher. So we'll say launcher t requires. It seems like we can actually do a lot of fun stuff. Yeah, we can do a lot of fun stuff, can't we? In fact, I could probably completely get rid of the concept of a discriminator and put the upload type on my upload class, and then use a strongly typed extension method on the requires method to establish which type is which. In fact, I think I might go ahead and do that. I think that'll be a little bit of a better way to go about writing this. And it'll also give us an example of how to use enums with Entity Framework. And that's what we're here for, to learn, right? All right, so let's go into upload, and let's say public launcher or upload type. So now we've added an upload type property to our upload class, which is going to be used as our discriminator column. Coming back into our database context, now instead of saying requires discriminator has value client, I could say requires type dot has value client. Or I think actually what I do is say type equals client. I also have a problem with my lambda. I use t twice, so I'm going to have to use t for my parent lambda and then m for my child lambda right there. And then we'll say map launcher m goes into m dot type equals launcher. Okay, so now basically what we've done is we've associated one of these enumeration members with one of our concrete types. Now I have no idea if this is going to work. I'm just guessing at syntax right now. But it does seem to... Okay, the expression should represent a property. So we do have to say type, we do have to point to type in the first one, and then we say has value. Configures the condition to require a value in this property. Rows that do not have a value assigned to column that this property is stored in. Okay, it looks like we're going to have to say requires, and then we're going to have to pass in a string. So we'll say requires type has value upload type dot client. See guys, isn't this fun? Then we'll say requires type dot has value upload type dot launcher, and then we'll do add the migration, and we get another exception because of course we do. This is why we can't have nice things. Upload type cannot be used as type discriminator. Supported types include byte, signed byte, bool, int 16, int 32, int 64, and string. That means we cannot use an enumeration as a discriminator type. How wonderful. Alright, well, maybe we can try this instead. Maybe we can try to cast it to an integer. Oh, hey, look. Okay, we got it. Woo! Alright, so, in short, the things that we have done so far is create a complex type mapping without using the complex type attribute. We did that, of course, with overriding the conventions and mapping the build number, mapping both its version and its timestamp. We've also successfully changed the discriminator from a string to an integer that's represented with a enumeration. At the moment, that enumeration will be mapped to our entity, but that's not necessarily required to be the case. I'll leave that property in our base type. It can't hurt anything. But the only reason why I wanted to make the enumeration in the first place was so that I could use a int-based discriminator and not a string-based discriminator. So now that I've done that, let's go ahead and update our database and see what happens. I'm going to type in update database, and see what we get. Oh great, what did we get? Problem mapping fragment starting at line 18. Condition member upload.type with the condition other than is null equals false is mapped. Either remove the condition on upload type or remove it from the mapping. Okay, let's not worry about mapping that enum. Let's go back into our upload class and let's go ahead and delete the type property. It's irrelevant, we don't need it. No pending explicit migrations, running seed method. So it successfully did do our mapping, but then it like died in a fire. Or it successfully applied our migration, but then it died. So what I want to do is I want to roll back that migration and reapply it. So let's go ahead and do. All right, so we're going to do update database with a target of one of these migrations. So what I want to do is I want to say update database, and then I believe it's target migration equals add upload tables. Target database is already at that version. Okay, so what I want to do instead is I want to do the one before it. So I want to say target migration equals create deploy token. This will roll my database down. If I can spell it right. It's create deploy tokens, not token. And we have reverted the migration. So we've removed our add upload tables migration. Let's go ahead and reapply it and make sure we don't get that nasty error again. Nope, we don't get that nasty error, so everything is good. Let's fire up MySQL Workbench and ensure that our schema is in a consistent state. What we should be seeing here, once I load this up, is we should see an uploads table, and we do see an uploads table. Let's go ahead and hit the alter button and see what schema it came up with. We have our version, our version timestamp, our type, which is an integer, which is what I wanted, and then our uploaded at. So this means our uploads table has finally been migrated. I know it was a bit of an adventure getting this going, just trying to deal with some of the odd behavior of Entity Framework from time to time can be a little frustrating, but fortunately we're able to resolve it simply by overriding the conventions, the convention-based mapping, with some explicit mapping here in our onModelCreating. The onModelCreating method is very powerful and allows us to override any aspect of the entity to table mappings, and we'll use it whenever the convention-based mapping simply isn't enough. And just to recap, what we did in the onModelCreating method was map a complex type, so a type that isn't a primitive type that can be easily mapped to a database, and B, allowed our discriminator column on our upload hierarchy to be based off of enumeration rather than based off of a string, which will make it more performant and more space efficient. And I prefer making my discriminator columns integers and not strings, because I find string-based discriminator columns are very, very ugly, and I don't like them. So yeah, I think that just about wraps everything up, and we'll see you guys in the next video.